Okay, so hi, my name is Justin Kim, and I'm here to present to you ReCodez, which is an intelligent and intuitive online coding editor. So here's an overview of the presentation. I will first be covering the background and motivation for creating this. Then I'll present my solution, as well as some of the challenges I faced. Then I will go into some of the experiments I ran in regards to ReCodez, as well as the conclusion and future work. So first, I'd like to talk about the growth of computer science. In 2018, there were 18.9 million programmers globally, and of this, 12.9 million were professionals. And the statistics show that by 2030, we will see around 45 million programmers. Now, I started off with this because 45 million programmers is a lot, and all of this means is there will be around 19 million or 17 million new programmers in the gap of about 10 years starting from now. So beginner programmers are learning coding. There's new beginner programmers every day, and they are what will become those 45 million people. And so if the average college graduate is around 22, then the people who will be in the programming workforce in the 2030s will be in their teens right now. And so these 10 years until 2030 will be crucial for these new minds to learn computer science. However, there is a problem, which is that there are several challenges for beginner programmers. There are two main challenges that I found. And these challenges may deter someone who has a passion in programming, and it'll be an obstacle for them to learn, and it may frustrate them to the point where they will stop learning programming, which is not ideal. The first challenge is that code must be free of errors. All code, in order to run, must essentially be perfect in terms of errors. There can't be errors in syntax or logic, otherwise the code will not function as the programmer intends. So I'm sure most of you have seen Python before. It's a high-level programming language that's very popular because of its accessibility to beginner programmers. However, oftentimes you will see errors in regards to indentation, where the lines are not spaced correctly, or a missing colon, where there's a colon missing in a function. And these are some of the common errors that appear when working with Python. Additionally, in Java and C++, you've seen errors with missing parentheses and brackets and semicolons. And all these errors go to show that these errors are relatively common. And for a beginner programmer, this problem is magnified because they might not know what kind of error they are looking for. They don't know that there is a missing semicolon, or maybe they don't know that a colon is required at this certain location. And so this will cause frustration in the beginner programmer. My second challenge is a lack of motivation. And although this seems a little bit harsh on the programmer, this problem mainly stems from the first challenge, where the programmer has to make the code perfect. And if the code isn't exactly functioning as they might want it to, the programmer will have to constantly edit and re-edit to fix the program, which could lead to a lack of motivation, a lack of desire to continue learning. So I put this symbol here to show that it's like a cycle of frustration where the beginner programmer will first see an error and will become frustrated by it. And because they're frustrated, they will begin to make more mistakes. And this will go into a spiral of frustration where they lose interest in computer programming, which is not what we want because coding is important. Almost everyone should know and learn how to code, and computer science is going to continue to be a large part of our lives. So everyone should learn to at least learn to code a little bit. And computer science is the future. And if someone doesn't know how to code, then they will be left behind as people learn more about computer science. So why did I go over those challenges? Well, mainly because those two challenges have to do with errors. Because coding is important, it's important to be able to fix these errors easily. And so I found several existing resources that can fix errors, or that help beginner programmers to fix errors. And they mainly fall into two types. So the first type is the question and answer type, where a programmer will ask a question and another programmer will answer it. This is mainly like Stack Overflow, where a beginner programmer can ask a question and a more experienced programmer can answer it. And the problem with this type of solution is that it takes time to search up the error, and the beginner programmer may not fully understand what the more experienced programmer is saying in regards to the error. And this will cause more confusion and frustration. And the second type of tool that can help to fix errors is the programming environment itself. So here are several common Python programming environments that usually include error messages that can pop up on your while you're coding and show you what is going wrong with your code. However, these error messages often do not completely describe what the error is, so the beginner is sometimes confused as to what they should fix. And sometimes the error messages are a little bit more complicated than they need to be, which could lead to additional confusion for the beginner programmer. So that leads me to my solution, ReCodez. It's an online tool to improve the experience of beginner programmers in learning how to fix errors. So similar to the programming environment, the code is built in to submit on the website. So you can run the code and compile it and see the output on the website. And this allows for more convenience, as the programmer doesn't have to copy their code into the website to determine what they should fix. However, what we do that's different is that we change the error messages. When we receive an error message, when we see an error message, we will reword them in a way that can make more sense to beginner programmer. And so instead of keeping the error messages in a hard to understand way, ReCodez outputs a improved version that will help them how to understand the errors and to fix the bugs. So there are several challenges that I encountered while creating this. Three main challenges. The first one was detecting errors. So there are several types of errors that can be present in a piece of code, such as syntax errors and arithmetic errors. With all of these different kinds of errors, detection becomes more difficult. And so in order to detect an error, you have to figure out what can cause that error. And this leads to creating an algorithm that can determine if the piece of code has an error. And so this was the first challenge. The second challenge that we encountered was describing the error. In order to make the errors more understandable, I had to figure out how to explain the error in a way that would make sense to a beginner programmer. And since beginners have different levels of experience in coding, there is no true one-size-fits-all for the description of the error. The third challenge was to find possible solutions to the error. How can I create a solution that will best fit what the programmer needs? Because there are many different ways to fix a problem, but there's usually only a couple that will actually fix it in the way that the programmer intended. So my solution was to use a combination of machine learning and algorithms to solve these three challenges. ReCodez currently is based on Python, and so all of the errors and explanations for the errors are based off of Python error messages and errors that they produce. So here is an overview of the solution. On the website, the code and output are exchanged with the error engine. The error engine will run the Python code through the interpreter and receive output and error messages. And the error messages are then sent to a knowledge base where they are compared, and the best explanation and solution to the errors are returned back to be presented back in the website. So the solution to challenge one, the obstacle of detecting the errors, I use the standard output of the Python itself, which will, as Python itself presents a error message of its own, I use that to determine if there was an error. And once that error was present, I took the entire error message that was provided by Python and put them into a current neural network to read through the message and determine two numbers that will be used later to solve other challenges. So the second challenge was, of course, to describe the error. In the error database, which was here, in this error database, there are several versions of the errors and possible solutions that exist. And so what I did was, using the recurrent neural network, it would output the error message that best fit what the programmer looked like it needed. So for the beginner programmer, let's say they are a very new beginner and they don't know much about computer programming, then the recurrent neural network will receive this information and return the error message that is geared towards the more inexperienced programmer. And so a more experienced programmer would receive an error message that looks more like the standard error message and more technical, and not as, because not as much of an explanation is required. And the third challenge was to present a possible solution to the user. And so similar to in challenge 2, what I did was use the recurrent neural network to pick a error message that would help to fix the solution in the way that the programmer probably intended. And so after many test runs, it learned to pick the proper solutions from the database. And the experiment. So to test ReCodez, we created 20 sample pieces of code, and all of these samples were simple and short. And what we did was run it through the program and try to determine if both the recurrent neural network was operating properly and that the explanations were clear and easy to understand. So we got some volunteers and put them together with this ReCodez and asked them to input the pieces of code which included errors. And once they received the error messages, we asked them to try to fix the problem in their code. And for after doing this, we asked them if they felt that ReCodez was able to help them in their understanding of the error messages. And so we found that ReCodez had a high level of people who felt that it was explained well. And some related work. So there are several companies that do similar things to what we do. For example, Pilot is a helper tool that can improve the code quality and does error detection. And however, ReCodez is a programming environment, a coding editor that combines all of these things into one cohesive whole, whereas Pilot is a helper tool, which requires the installation of additional software. And ReCodez is just more cohesive and together. Another resource is Stack Overflow. Stack Overflow, as I mentioned earlier, allows beginner programmers to answer and ask questions. And there is a tool that allows Stack Overflow to be integrated into a coding editor. However, this again requires installation of extra additional software, and we felt that ReCodez, as it's online, it is more convenient and able to be used more effectively. So some future work. There are limitations of ReCodez, and of course, most of them lie in the error detection and solutions to the error. Because what I have to do is create error messages and error solutions to every single possible error that could be written. This is obviously not a very sustainable solution, and it requires a lot of work to build up this database. So in future work, I am planning to combine possible Stack Overflow integration such that the questions will be matched to an answer in Stack Overflow and automatically produced in the website, allowing for a more convenient workaround. And so thank you for your time.